This presentation explores advanced methods for forecasting capital and revenue expenditure using statistical modeling techniques implemented within Excel. We will cover fundamentals, various statistical tools, risk assessment, and model accuracy to support better financial decision-making. Understanding the basics of CapEx and RevEx is essential for accurate forecasting. We will define these expenditures, highlight their differences, stress the importance of precision in forecasting, and introduce Excel as a key platform for financial forecasting. Capital expenditure involves long-term investments in assets, whereas revenue expenditure, RevEx, covers day-to-day operational costs. Differentiating these helps in applying appropriate forecasting methods and budgeting strategies. Accurate forecasting supports budgeting, resource allocation, and strategic planning. It reduces risks, improves financial control, and helps organizations meet their financial goals effectively. Excel offers powerful tools such as formulas, pivot tables, and data visualization which make it an accessible and flexible platform for creating financial forecasting models tailored to organizational needs. We will explore key statistical techniques such as regression and time series analysis. These methods can be integrated into Excel workflows to model expenditure trends and improve forecasting accuracy. Regression analysis helps identify relationships between variables and predict financial outcomes. In Excel, functions like LineList and Data Analysis Toolbox support building regression models. Time series analysis examines data points over time to identify patterns and seasonal effects. Excel features like moving averages and exponential smoothing can be leveraged for this purpose. Combining built-in Excel functions with statistical models enables dynamic forecasting. Automation through formulas and macros enhances efficiency and accuracy in financial analysis. Monte Carlo simulation uses random sampling to model uncertainty in forecasts. This section covers the concept, implementation in Excel, and how to interpret simulation results to understand risks. Monte Carlo simulation generates numerous scenarios by varying input variables randomly, providing a probabilistic distribution of possible outcomes to better capture uncertainty. Using Excel's random number functions and add-ins, Monte Carlo simulation can be set up to run multiple iterations of expenditure forecasts efficiently. Simulation outputs are analyzed statistically to evaluate forecast confidence levels, identify potential risks, and aid in informed decision-making under uncertainty. Decision trees provide a visual and analytical method for evaluating different forecasting scenarios. We will discuss decision tree basics, building them in Excel, and comparing their outcomes with other models. Decision trees map decisions and possible outcomes, including chance events, costs, and utilities, making them ideal for complex expenditure forecasting. Excel tools and add-ins support the construction of decision trees, facilitating scenario evaluation and helping to identify optimal forecasting strategies. Decision trees complement other statistical models by providing scenario-based analysis. Comparing results helps validate forecasts and choose the best approach. This section covers methods to test how changes in assumptions impact forecasts. We will explore scenario and sensitivity analysis, and discuss how to incorporate CapEx constraints effectively. Scenario analysis evaluates multiple sets of assumptions to understand their effect on financial forecasts. Excel's Scenario Manager is a useful tool for this purpose. Sensitivity analysis identifies which variables have the greatest impact on forecast outcomes, helping prioritize focus areas for accuracy improvements. Accounting for budget limits and regulatory constraints on capital expenditure ensures realistic and actionable forecasts while maintaining compliance and strategic alignment. To ensure reliability, we review key accuracy metrics, validation methods including backtesting, and approaches for continuous model refinement in forecasting. Metrics like mean absolute percentage error, MAPE, and root mean square error, RMSE, quantify forecast performance, providing benchmarks to improve models. Backtesting uses historical data to compare forecasted and actual results, validating model robustness and identifying areas needing adjustment. Ongoing model refinement through iteration, new data incorporation, and stakeholder feedback ensures forecasts remain accurate and relevant over time. By leveraging advanced statistical models and Excel's capabilities, organizations can enhance the accuracy and reliability of capital and revenue expenditure forecasts, enabling better financial planning and risk management.